Okay, I just started the recording. Okay, now what I'm saying is, if you're trying to prefix a value with 0b, it means that you are intended to initialize the binary value, but you are trying to give not allowed binary values, which are other than 0 and 1s. So which are not allowed. You can give 0 1 0 1 something like that, or triple one, or double one double one, or anything you can give, but it should contain only zeros and ones. If you see, now you will not get any error. Okay, now a doubt is, if I print val, what will come? What it will come, guys? I hope many of you might have studied or gone through binary values, but I'll explain now how to convert the binary value to normal value. Do not worry. Now, if you see, okay, 0 1 0b, you are not supposed to care. Okay, that is just a specification to define that I'm going to initialize a binary value. But all that we need to care is 0 1 and 0 1. So this is the value that we need to worry about. Okay, this is the value that we need to come into the consideration. So if you see the output, if I'm trying to print the val variable, it is printing 5. How it is treating the 0 1 0 1 as 5? Okay, that is what the binary conversion. So we need to, there is a formula, let me tell you how to convert, how it is taking the binary value 0 1 0 1 to 5. Okay, please carefully listen, guys. I'll explain for binary properly, but remaining things for octal and decimal, you need to take care. Octal and hexadecimal, you need to follow the same rule. Just spend good time here. Let's spend good time here. Concentrate on it. Now we are giving val equals to 0b 0 1 0 1. So 0 1 0 1 is becoming a, okay, 0 1 0 1 is becoming what? 5. The output of 0 1 and 0 1 is we got as 5. How we are getting it? Now if you see, there is a formula from the right side. If you start, what is the base of binary, guys? The base of binary is 2. Yes or no?
Yes, sir.
Are you able to follow me? Yes. The base of binary is 2. Start from the right side and give, do 2 power 0. Okay. 2 power 0 and 2 power 1. Okay. Then 2 power 2 and 2 power 3. You should start from the right to left, and you need to give the increase the value, the power value. The base value will be common. Because why am I treating the 2 here? Because 2 is the base for binary numbers. That's why I'm treating here. Now, if you see, it keeps on increasing. 1 0 1 2 3. So now we have only 4 values. That's why I stopped at 3 only. 0 1 2 3, total 4 values. Now how we need to count it? So no, we need to count it as 2 power 0. What is the value of 2 power 0?
1.
Sorry?
1.
Yes. Anything power 0 is 1. Yes or no, as per maths? Okay. Now 1 into 1. Why I'm giving 1 here? 1 into 1. 2 power 0 is nothing but 1. And in the value also it is 1. 2 power 1 into 1. Then next 2 power 1. What is the value of 2 power 1? 2. 2. 2 into 0.
0.
Yes. 2 into 0. I'm just appending plus here. So every value we need to sum here. Next 2 power 2.
4.
2 power 2, 4. 4 into 1 plus this one. Okay. Next 2 power 3.
8.
8 into how much? 0. There we go. We are done. Now tell me the output. Total output of this. How much, guys? 8 into 0.
0.
0
0.
plus 4 into 1. 4
4.
plus 2
0.
into 0. 0 plus
Plus
1.
1.
1 into 1. 1 equals to
5.
5.
0 plus 4 plus 0 plus 1. How much? 5. That's what we got it, right? Come on, folks. Yes or no? Is it clear? Is the formula is clear?
Yes.
Yes, sir.
Okay. Awesome. Next, let's do 1 or 2 exercises so that we'll be very good in the formula, and then we can go ahead for the hexadecimal and octal forms. Okay. Now, this might be useful for your what are these exams. So there will be some written tests, right, in the interview. So it might be these kind of things might be useful for that, but we rarely use in real time. Okay. Value. So now I'm giving one more variable. For example, a equals to 0b 111. Can someone tell me what is the output for this? I'm just giving only 3 values.
7.
I think it's 7.
7. Great. So why it is 7? If you start from the right side, it will be these 3 values, it will be considered. And if you see 2 power, 1, 1, 1. So I'm just repeating, guys. So here it will be 2 power 0. Here it will be, just let me copy paste this. Why to waste your time? Okay, so if I give like this, 2 power 0, how much? 2 power 0 is nothing but 1, and 2 power 1 is nothing but 2. 1, 2 power 0 into 1, 1. 2 power 1 into 1, 2. 2 power 2 into 1. 2 power 2 is nothing but 4. 4 plus 4 into 1, 4. 4 plus 2 plus 1, how much? 7. That's what we got it. Okay. So if you don't want to consider this 2 power 0 and all, one simple rule is you need to from right side you need to keep on increasing something like this, guys. 1, sorry, 8, 4, 2, 1. So 2 power 0 it will come 1, 2 power 1 it will come 2, 2 power 2 it will come 4, 2 power 3 it will be 8. So next if you keep on increasing 16 and all, 2 power 4 it will become 16, 2 power 5 it will become something 32, something like that it will be. Okay. You need to keep on increasing them. You need to multiply 2. 8 into 2, 16, 16 into 2, 32. Like that, you can keep on increasing based on the numbers that you have initialized. Is there any doubt or any confusion here, guys? Are we clear on the formula? We are able to convert any bigger number also using this.
Yes. Yes, sir.
Okay, fine. That's how we can we deal with the binary numbers. And if you are based even binary number also, if you're trying to print it, it will print as a normal number. That is what ultimately we want to do. So it might be in the form of binary, but if you try to print it as another variable, or if you try to use it as another variable, it will be treated as a normal number only. Like we have a 0101 returns 5 and a 111 returns 7. Similarly, this one also same. Okay, we're good for binary number. Next, we'll go for octal form. What is the meaning of octal? Octal form is nothing but, what is the base of octal? The base of octal is 8.
8.
Great. So the base of octal is 8. It means that any number that you want to define in octal form, it should contain 0 to 7. 0, 1, 2, 3, 4, 5, 6, 7. Okay. More than 7, other than these numbers, if you try to give us inside octal form, it will give us syntax error. Okay, how we need to represent this? How we need to represent the octal form? Like we prefix the 0b or 0 small b or 0 capital B, for octal form also we need to prefix 0 capital O, 0 small o. Literal, okay, literal value should be prefixed with 0 O or 0 capital O. Okay, and one more thing is the allowed digits are 0 to 7. 0s 1, 2, 3, 4, 5, 6, 7. These numbers only allowed. For example, A equals to 0 capital O 1, 2, 3. If you try to give 8 or 9 here, it will fail. So let me show you here. I'm just commenting out the other one. I'll tell you what is the comment and all. I'll just take a minute today and I'll explain you what is the comment. Okay, now I'm giving A equals to 0, O, 1, 2, 3, 8. Okay, so what are the allowed values? Allowed values for octal form, it is only 0, only 0 to 7. If I'm trying to run it, it will throw an error. Where it is giving an error, invalid digit 8 in octal literal. So when you're trying to define as an octal, you should follow the rule. The rule is it contains the base as 8. It means that 0 to 7 only allowed, not more than that. I'm just giving 1, 2, 3. Okay. With the same formula, with some common sense, can anybody tell me what is the output of this 1, 2, 3? And can you help me to understand to resolve this, to create this formula for it? The value is 1, 2, 3. 1, 2, 3. We need to convert this into a normal number. How can we get it? Similar rule you need to follow. Here you are giving 2000, 2 power 0, 2 power 1, 2 power 2, 2 power 3 like that. Why we are giving 2 here?
Because it's a binary.
Yes. In that case, here we need to, what we need to use here?
8 power 0. 8
19 is wrong.
So here we should use 8 power 0, 8 power 1,
8 power 2.
8 power 2. We can keep on going like that, but we have only 3 values here in our case. 8 power 2. Okay. Now tell me what is the output for it?
83.
8 power 2 is nothing but 8 into 8, 64. 64 into 1.
Oh, sorry.
Plus 8 into 2. How much?
16.
16.
8 into 2. Plus 8 power 0 into 3 means 1 into 3. 1 into 3. Now how much?
83.
83, right?
81.
64 plus 3, 67. 67 plus 16, 83, right? Come on, guys. Any confusion?
Yes.
64 plus 16 plus 3. Am I correct?
Yes.
83. Are we able to crack the formula? Now, if I am trying to print A, it should print 83. Otherwise, our formula is wrong. We are wrong. But no, it cannot be wrong. So if you see, 83 is the output. Are we good? Are we able to crack it? With the same knowledge that we have on binary numbers, same formula we need to apply. But the base value we need to change. Come on, folks. Yes or no?
Yes, sir.
Can we go ahead, or we need to do one more exercise? Can we go ahead with the hexadecimal?
Yes,
Okay.
we'll try one more example.
We'll try one more. Huh? Sure. Okay. Now I'm giving A equals to or B equals to 0, capital O. I'm defining it as binary. Now I'm giving 1111. Now, can someone tell me what is the output of B? Let's do one more exercise here. 1, 1, 1, 1. Formula remains same. Okay. And we need to give, we have 4 values here. We need to give one more value. 8 power 3.
585.
585 we got. Huh?
Yeah.
Okay. 8 into 8, 64. 64 into 8, how much?
512.
512. Great mathematicians are here. Okay. 8 into 8, 64. 64 into 1, 64. Plus 8 into 1, 8. Plus 1. 8 power 0, 1, 1 into 1, 1. How much? 512
585.
plus 64 plus 8 plus 1. How much? 585. Huh?
Yeah.
Yes, sir.
Okay. Are we good? Are we good with the formula? 585 we got it. Are we confident now? My dear friends, yes or no?
Yes, sir.
Okay. Let's go to hexadecimal. What is the meaning of hexa? What is the base of hexadecimal?
16.
Yes, hexadecimal form. And base is 16 here, interestingly. We need to spend much time to calculate here. Okay, hexadecimal form. The allowed digits are, what are the allowed digits? So there should be 16 digits, right? How many digits we have overall?
0 to 15.
Yes, 0 to 15, that is correct. But numbers we have only 9, right? 0 to 9 only, right? Okay, so what are the allowed digits?
When you
Yeah,
take A, B, C, D,
then
0
A
to
to
9,
F will
A to
get.
F.
when you take A, B, C, D.
A to F.
Yes, exactly.
Alphabet.
So since we have only 10 numbers, we will take the remaining 6 numbers as A to F. That can be small or that can be, capital also. So the allowed digits are 0 to 9 and A to F. I'm just saying it can be both small or both lower and uppercase. Okay. A to F, A, B, C, D, E, F. So 6, right? So total it will be 16 letters. Next, here also the literal should be prefixed with what? Hexadecimal. We need to give capital X or small x. 0 capital X or 0 small x. Then only it will treat it as a hexadecimal number. Otherwise, you are going to give a normal number or normal string. Okay. So, for example, hexa and something like ABC. And one more example, 0 small x, 1, 2, 3, 4, anything. So I'm giving you, I'm giving this to your for you as an exercise. Please just calculate it and tell me the output. I'm not going to print it, but you can calculate it. Don't calculate it now. Maybe you can try it out at your home and just tell me. Don't print it. Don't simply just print it and show me the output. Calculate it on your pen and take the pen and paper and calculate it, or take the notepad and calculate it and show me the formula similar to this. Similar to this, show me the formula and prove me that this is the output that I got. Are we good? Will you be able to do that for hexadecimal?
Yes.
You should do that. You should do that. Okay. Next thing is. So I'm not calculating it. You take care of calculation and show me the formula. And that is one of the exercise for tomorrow. One of the assignments for tomorrow. Okay. Next we'll go for base conversions. Okay. Base conversions. What do I mean by base conversions here? Just in case, if you get a requirement, for example, you have a binary value and you have a hexadecimal value, or you want to convert the binary value into hexadecimal form, or you want to convert the normal value into a binary form, or binary value into a normal form. That anything is possible, right? If you want to do anything from binary value to if you want to convert the normal value to binary form, or octal value to binary form, or hexadecimal value to binary form, then you may be a chance that you may get some chance like that. So in that case, we have a beautiful functions given by Python. We need to use it. Base conversions. In any situation, if you want to convert one base to another base, like binary form to hexadecimal form or vice versa, then you can go for these things. So you want to get, there are few predefined functions. So Python has provided inbuilt functions or predefined functions for base conversion. Okay. So now if you want to convert from one type to another type, you should have a specific method for everything, right? So if you want to convert from other types to binary, then we have a function called bin function. So just remember one thing, guys, anything that you enclose with the parenthesis, that is treating as function only, that we call it as a function or method. Okay. So bin function. So bin function, what is the purpose of bin function is from any other type, from any other base. It can be a decimal or it can be a octal or it can be a hexadecimal form. If you want to convert from one form to a binary form, any other form to binary form, then we can go for bin function. So we can use this to convert from any base to binary. You can convert it. Example. So I'm taking one decimal value, a equal to 12. 12 is a decimal value, right? Now I want to convert a 12 into binary. What we can do? You can simply give a equal to bin of a, or you can use take another variable otherwise. B equal to bin of a. So inside this bin function, I'm passing the a value because a is the variable which is holding the decimal number, and that decimal number I want to convert into a binary form. So that whatever the value that you want to convert, that value you need to pass as an argument. Argument is nothing but whatever you are passing inside this parenthesis. Okay, that we call it as a arguments or a parameters. Please remember these naming conventions, terminology we will be using daily. Okay, so now this is how we need to do is using a bin function. Now the 12 will be converted into a binary form. Binary form is nothing but zeros and ones only it will contain. So let's see how it will print. So base conversions. I'm just going to comment all these things. Last 5 minutes I'll take to explain about the comments. Okay. Base conversions. A equal to 12, and I'm I'm taking one more variable and I'm converting the 12 into a binary form. Bin of 12. So bin is a predefined function. So it is automatically came, we did not create it. It is created by Python. If you simply mouse over on it, if you can simply, if you want to go to this function, inside this function, what you can do is mouse over on the bin and click on control. Automatically, this hand icon, it will be shown, and click on the button. Right click on it. Sorry, left click on it. Then you will be able to go to this function. If you see, this is the Python file. built-ins.py file. That is, this functions are created by, and this file is created by Python only. Along when we are installing Python, all these files will be included in our local system automatically. We did not create it. Did we create this function? No, we did not create this function. Automatically, Python has given for us. And if you really see the beautiful way of representation they have done here. Return the binary representation of an integer. So bin function, what it will do? It returns the binary representation of an integer or any other value. So they are trying to do 2 lakhs or 27 lakhs 96,202 value into binary form. So this is how it is converting the binary form. Similarly, okay, we don't need to worry about this and go inside it. I'm just giving an idea what is happening inside. Internally, what is happening. So do not believe it blindly because we are developers. Without logic, we should not believe anything. Now, print B. Now, if I'm printing B, what will come? If you see, what it is coming, guys? 0B 1111. Sorry, 1100. If you convert 1100 into a normal form, it will be again 12 only. Sir, no. 2 power 0 into 1, 0, 0. 2 power 1 into 0, 0. 2 power 2, 2 power 2 into 1. How much? 4. 2 power 3 into 1. How much? 8. 8 plus 4, 12. Are we good, guys? Are you getting what I'm trying to say here? Come on, come on. The lot of silence here now.
Can you just explain once more about base conversion?
Yeah, sure, Farhan. Okay, base conversion is something. So now there may be a chance in future or while you're coding something. The value is in a octal form, for example, or the value is in a normal form. Normal form is maybe normal number. But you have got some chance that you need to convert that that form into a binary form. Then we should have some facility, right? How we need to do programmatically. So for that reason, the Python has given some built-in functions. If you want to convert from any other form to binary form, then you can simply use bin function. That will automatically take care and give you the binary form. Okay.
Okay,
yeah. Guys, you can if you still not understand, please tell me. I'll repeat it in another way. Are we good? I'm getting some messages, but if you can respond, that would be good for us. Okay. I hope everybody got the clarity now. So if you want to convert from one type to another type, one form to another form, you need to go for these base conversions. That's it. Not much. Now I'm taking one more value. C equal to, I'm taking an octal form. So this is what? This is a decimal form. Decimal form. And this decimal form, what we are trying to do? We are trying to convert the decimal form into a binary form here. Now again, I'm giving a octal form. 0, O, 111. So 111. This is what is the form? This is octal form. So now I'm trying to convert the octal form into decimal form. So sorry, binary form. Bin of, what we need to do? Bin of C. So if you print this, we will get the final output. Bin of C means what? 00111. This is the octal form. I'm trying to convert the octal form into a binary form. So that the binary form will print. Bin of C. C is the value of octal, and octal I'm trying to convert into binary form. So if you see what is the output, it should come in the zeros and ones only. If you see the bigger number, it came because octal 111 means it might be a very big number. Okay, if you try to convert again this binary form into normal number, and both the octal form value and this value will match. Okay, let me explain another way. So now this is octal form, guys. I'm just giving octal form as 0012. What is the value of 0012? Can someone tell me by using the formula, octal formula? 12. What is the output of 12?
10.
Octal. 8 power 0
8,
into
9,
sorry 10 na?
9, 9.
10,
Okay.
sir.
10 it will be, right? 8 power
Yeah.
0 into 2.
Yeah.
1 into 2, 2, and 8 power 1 into 1. So
8 plus 2, 10.
10. Okay, very good. Now, so here, if you convert to the actual number, it will become 10. But what we are trying to do here, the same 10 representation, they want to convert into a binary form. They don't want to represent this in an octal form. They want to represent in a binary form. How can we represent the 10 into binary form? Something like this, 8421, right? 8421 it is giving. So in the best possible way, they will try to fit in. Okay, 8421. The binary form is, it contains 8421. So if you want to keep the 10 value here, what we need to do? 1 at 8th place 0, and in place of 2 we'll give 1, and in place of 1 it will give 0. 1010 will become 10 or not? Come on. 1010 will become 10 or not? How we represent the?
Yeah. It's become 10.
Yes. So that is what it internally will do. 1010 it will become. Because the 10 value, they are representing the octal form. They are simply, we are trying to convert using the bin function. We are converting into a binary form. If you see 0B1010. So if you convert 1010 into a normal form, it will become 10. Both will become 10 only. We are not changing the actual value. We are just changing their form using the predefined functions. Are we clear? Is that clear, guys? Okay. Farhan?
Yes, sir.
Okay. Good. Next. So we tried converting decimal to binary and octal to binary, and from any form to binary we are trying to do. Next we'll go for hexadecimal. I'm not taking bigger value, we'll take only small value so that you'll understand better. Concept is very, very important here. Next I'm taking hexadecimal value. 0x12 again. 0x12 will become how much? Will become, way to convert it. OX is not defined. Sorry.
I think it's 18 because 16 power 1 into 1 plus 16 power 0 into
Oh, just a second. Okay. I'm just gave over here. Okay, 12 will become 18.
18.
Okay, 18 it will become. But that 18 we are trying to represent in the binary form. I'm converting this octal form into, hexadecimal form into a binary form. Okay, what they will do, 18. What is the best way to represent the 18? They will try to fit in those values. So next, what will become? Something like 16, 8, 4, 2, 1. So if you want to keep it as, 18, right? If you want to represent this as 18, what is the best way, guys? They will write one value at 16. The remaining values are 2 is there. 16 plus 2, it will become 18. That is sufficient, right? Folks, 16 plus 2, it will become 18. That is sufficient, no?
Yes.
Remaining places, they'll put 0. 2, 1, and remaining place 0. 16, 1, and 2, 1. So 1, 0, 0, 1, 0 should be the output. We try to convert the D into binary form. Bin of D. So we see 1, 0, 0, 1, 0 is the output. So that's how it will convert internally. Simply, we are trying to convert from other forms to binary form. That's why we are using a bin function. That's it. What it will do internally also, you really don't need to take care. But the thing is, we need to understand what is actually the binary form is doing. So that's why I'm just explaining the internals of it. But automatically the conversion will take care of the bin function. I hope you are clear. Next we'll go for another function. Now we are good. We have a bin function to convert from other form to binary, but we should be having there may be a reverse is also possible, right? We might have to convert other form to octal form also. Like binary form to octal form, like hexadecimal form to octal form, normal decimal form to decimal value to octal form. That one we might have to do, right? For that function, they might have given, they have given one more function called OCT, oct. They have given oct function. Oct function. What this function will do? Using this function, we can convert from any base to octal form. Are you able to follow me, guys? Why do we need bin and why do we need oct? I'm not getting the good response. Is there any confusion?
No, sir.
Okay. You're simply not responding, so you're clear. I hope, I'm believing. So please let me know if you're still having any confusion.
Please repeat.
Sorry, Farhan.
Yeah, can you just repeat the conversion from octal?
Octal. Yeah, octal I'll convert. I'll explain octal now. This one only, right? You're saying.
Yeah, that one.
Yeah, I'm gonna talk about it now. I just want to check that with the bin you're clear or not. Okay, now let me show you octal function. So the oct function is the definition is from another form to octal form. Simply, and that can be a decimal form, that can be binary form, it can be any other form. Just want to convert from other forms to octal form. So now let me see the final value, the final output will be in the octal representation only. So let me take one more value. Okay, I'm just commenting it. So now if you want to convert oct of 10, I'm not taking variables now, I'm just simply taking the values. Oct of 10. 10 is what? 10 is the decimal form. So what I'm trying to convert? Decimal form to octal. 10 is a decimal value. Trying to convert the decimal value into an octal value. So what will be the output? 10 will be represented in the octal form. So how the octal, what is the 10 value? How we can represent the 10 value? 0012. 0012 is the octal representation of 10. If you see here, we already tried here. 0012. What is the final value? 10 is the final value. So we are doing the reverse here. 10 we are giving and 10 we are trying to convert into an octal form. So that will represent something like 012. Okay. If you take any other value, any other decimal value again, 12. How the 12 will be represented? It will simply convert into octal form. If you see 0014. 14, if you try to convert, it will be at end of the day, it will become a 12 only. Because 0014 means what? 14 octal form. 8 into 8 power of 0 into 4 means 1. 1 into 4. 8 power of 1 into 1. 8 plus, sorry, it is 8 power of 0 into 4, right? So 1 into 4, 4. 8 plus 4, 12. Okay, so that's what it is doing. Sorry. Yeah, correct. 12. That's what it is doing, right? So 0014. That conversation is automatically internally take care. You don't need to do it. I'm just explaining you for your better idea. Farhan, is it good now for this?
Yes, Shyam.
Cool. Now we'll try to convert from another form to octal form. Another form is nothing but can be hexadecimal or binary form. I'm taking a binary form. 0B 1111. What is the value of 1111, right, guys, in binary? What is the value of 1111?
It's 15.
It's 15, right? How we can represent 15 in octal form? That will be taken care by oct function. So oct function will convert the 15 value into octal form. 17. 17 will return 15. So that is what they are saying. So 17, if you keep 7 here, so 8 to the power of 0 into 7. 8 to the power of 0 is nothing but 1. 1 into 7, 7. 8 plus 7, how much? 15. That's what they are doing. 0017. Sorry, 0017. That's not 0, that is O, octal. Okay, that's how we can convert it. Next, hexadecimal also. If you want to convert hexadecimal, 0x12. This conversion is nothing but hexadecimal to octal. I'm trying to convert all the permutations and combinations so that you'll get fair idea. 0x12. What is the value of 0x12? 18. Hexadecimal. If you convert hexadecimal to binary value, it will be a normal value, it will become 118. How we can represent 18 in the octal form? 18. So if you see 0022. So 22 2 will become 18. So how it will become 18? 2 and 2. So 8 power of 0 into 2. 1 into 2. 2. 8 power of 1 into 2. Again 16. 16 plus 2, it will become 18. Okay, so it will become 18. So 0022 is nothing but 18 only. I'm saying here 0022 is equivalent of 0x12. But this representation is hexadecimal form and this representation is, sorry, 0. This representation is octal form and this representation is hexadecimal form. But the value is same. That is what I mean to say. The final value is same. We are simply doing the conversion. The form is different. I hope you are clear. Next, hexadecimal. Similarly, like we have in bin function and oct function, for hexadecimal also there should be having some function, right? Because hexadecimal from other form to hexadecimal also we might have to convert it in future. There may be a chance. So what this hexadecimal hex function will do, converting from another option, another function to hex form. Let me just keep this. Just a second. I'll give a separate material also though, but I'm just keeping the screenshots for your reference. Okay, for your reference, I'm just keep pasting the screenshots here, side by side. I'll just attach this notebook. Next, binary also I'll show, bin function also. Okay, side by side to bin function. Okay, next. Third function is hex function. Hex is nothing. What is the function will do? This function will convert from another form to another form is nothing but any other form. It can be binary form or octal form. It will try to convert another base to hexadecimal. We use this function. Use this to convert from any other base to hexadecimal. Okay. So similar to similar to octal or binary, where we can convert from other types. So something like print of hex of 20. 20 is the normal value I'm trying. So what I'm trying to convert here, 20 is the decimal value. Decimal value to hexadecimal value. Okay, 20. So how we can how would it will convert 20 to hexadecimal? Hexadecimal means 16 base. So 16 base it will take 0x14. So let me comment the other stuff. 0x14. 0x14 if you try to calculate 16 power of 0 into 1. 1 into 4 only, and 16 power of 1 into 1 16 plus 4 it will become 20. You can convert it if you want to validate it, you can convert it. So hex of 20 it will be the 14. Next, and let me take a binary value, one binary value. Hex of 0b 1 1. Simply taking 1 1. Let's see what will become. 1 1 is nothing but how much? What is the binary value of 1 1?
3.
3 only, just 3. Binary T. What are we doing here? Can someone tell me what are we doing? Technically. What is the functionality this line is doing?
We are converting binary to hexadecimal.
Awesome, awesome. Yes. We're converting binary to hexadecimal. Okay. So this actual value is 3. How the 3 will become hexadecimal form? Let's see. That is because that is very, very small number. If you see 0x3, you know how why 3 it is? 16 power of 0 into 3. It will become 3 only. 16 power of 0 is nothing but 1. 1 into 3, 1. Okay. So 0x3 is actually equivalent of 0b11. This form is binary and this form is hexadecimal. But the final value, if you try to convert, both the values will return 3 only. Next, print of hex of. Next, what is the other form that we have? Octal form. 0O. Octal form will try to convert 1, 2, 3. What is the value of 1, 2, 3? Just a second. What is the value of 1, 2, 3 in octal? What are we doing here? Octal to hexadecimal. Okay. 1, 2, 3. So if we, I think 8 power of 0,
35.
35. So what is the equivalent of 35 in hexadecimal? So that will print. That 35 will be written to hexadecimal form. So 53. If you convert 0x53, 0x53. So 53 means 5 space 3. 16 power of 16 power of 1 into 3. So 16 plus it is 16. 16 into, sorry guys, what is the value of 1, 2, 3 in hexadecimal? Bigger number, right? 1, 2, 3. 1, 2, 3 is nothing but, okay, let me show you the conversion. Hexadecimal, octal form 1, 2, 3. 1, 2, 3. 8 power of 0 means 1. 8 power of 1 into 2. How much? 16. Okay. 8 power of 3 into 1. 8 8s are 64. 64 into 8. 64 into 8. 512. 512 plus 16. 512 plus 17. 16 plus 1, 17. So it will become 529. This is octal form. But if you go to hexadecimal form, what is printing? 53. 53 is nothing but in hexadecimal form. 53 means, sorry, 53. Don't read it as 53. 53. 53 means 16 into 16 power of 1. Nothing but 16 only. 16 into 5. 16 into 5 plus next 16 power of 0. How much? 16 power of 0 is nothing but 1. 1 into 3 is equal to, let me calculate, 16 into 5.
93.
93 only, yeah. 16 into 5. 80. 83. But this is very small number. How we got 529 here? We're
The
missing
octal form is wrong.
Octal form is wrong. Huh? Yeah, we missed some logic here. Okay.
Correct.
So the highest number is 8.
8 power into 0.
8 power 3, 8 power 0, 8 power 1, 8 power 8.
8 power 0. It is 1. 1 into 3. 3.
We can get 83
16.
if you calculate that.
Yeah. So 8 power 1. Okay, right. So we did 8 power 1, I think, in the last time. 8 power 1 into 2. How much? 16. 8 power 2 into 1. 64. Right. This one we miscalculated. We did it as 8 power 3. Now it will become 83. So both are same. It should be same. We calculated wrong. Okay. So now if you see, what I'm trying to say is 0, 1, 2, 3 is equivalent of 0x53 in hexadecimal form. Both are same. The form is different. The values, final output is same. 53. So 0, 1, 2, 3 is nothing but 0x53. Okay, this is how we can convert from one form to another form and multiple forms also. Different forms, how we represent the multiple forms. So this is how we can do. I hope we are clear, guys, till now.
Yes, yes, very clear.
Next, we'll go for the another data type. What is the next data type? The primary data types. If we go
Float.
The float, we'll discuss about float. I'll take a new one. Float. When do we go for float data type? And what type of data we can store in the float data types, vice versa. Okay. If you want to represent any floating values means anything that has points Like we have a pi value 3.147, and we have some percentages, and we have some salaries. When do we go for float data type in real time? I mean, what kind of data we store? If there is a salary, what is salary? How the salary will looks like, guys? Any price, for example, price of some Amazon item. What is the price will be? Something like 10,000.00, 10,000.33 something paise and all. We always represent the data of the any price. It can be salary or that can be item value and all. We keep all this kind of data in a points only. We prefer to keep this kind of data in the points. So that kind of data we call it as float data type. We can use this data type to store or represent floating point values. Example, A equal to 3.147, just a calculation. And I want to give my the percentage. I want to marks percentage or CGPA. I want to just calculate my CGPA. Then what is the basically our percentages will be, guys? It never be accurate, right? It will always be contain some points. Even if it is accurate, we'll keep it as 0.0. My percentage, for example, 73.9% is what I have. Just an example I'm saying. So this is how, if any value that you want to store, the pointer values you want to store in your code, that representation will be treated as float function. Sorry, float data type. That will comes under a float data type. Okay, now tell me how to find out what is the data type, which data type how to find out the data type of variable. I already told, if anyone of you remember, how to find out the type of variable.
By using type function.
Exactly. Awesome. Okay, using the type function, you can understand what is the type of this variable. Float data type. A equal to 97.3% I have, for example. Now you want to find out what is the type of A. I'm printing type of A. So it should print float. You remember, you just forgot about this class keyword. That will come in the OOPS concepts, but only concentrate on this float. Float is a predefined data type that you are able to see here. That is automatically allocated based on the data that we have given. Data is in the form of float. So if you are trying to check the type is returned float only. Okay. Similarly, any data that you want to store, you can store it in the any data that you want to store in the points values, that will be treated as a float only. So like we have in another forms, float, we don't need to keep it in another form. This will be very straightforward. But if you really want to keep it in the binary forms and all, so that's not actually possible. That will be treated as invariant syntaxes. So for example, if you want to convert it as 0x97.3 and all, that is not possible. Because point is actually a matter here. Point is not available in the A to 0 to 9 and A to F. Okay, point is out of control here. So like we have an integer, we have a multiple forms, right? In floating points, we don't have multiple forms. This is only one form. Whatever the data that contains in point values, that will be treated as float. There is no forms like decimal, binary, hexa and all. That's not possible here. That is a very, very important note that you need to write. Note. Like we have int forms, different forms in int, like decimal, octal, hexa, binary, we cannot represent float values. Okay, example, if you're trying to attempt it as a equal to 0b 1.01 or something like that, if you try to give, it will throw invalid syntax. So this kind of representation in the points, it is invalid. We cannot do that. That's it. Next, this is very simple, straightforward data type, guys. Next data type, complex data type. Complex. How many of you remember complex value in your maths?
Messi.
Sorry?
It's A plus BG. Yeah.
Exactly. So awesome. So complex is one of the mathematical form that contains the two parts. One is a real part and another one is the imaginary part. Okay. A complex number. This is also we rarely use in real time. But if there is any mathematical application that if you are working on, then we might have to use a complex data type. But we rarely use. Out of my 8 years of experience, I never used it. I never got a chance to use it. Because this will be used only in the mathematical applications only. A complex number is one of the mathematical forms. It contains two parts. One is imaginary, one is real part, and another one is imaginary part. Let me show you. For example, the syntax is A plus BJ. J is common here. So this A is nothing but a real part. Okay, this one we call it as real part. And this B is nothing, this BJ is nothing but imaginary part. Okay, so just an example. Val equals to 10 plus 20j. So in this example, 10 is a real part and 20j is a imaginary part. Okay, one more thing. So here, one more note point you can mention. One more note I want to mention here is, so here there are two things, right? A and B. A plus bj. This is the syntax. A can be any value. B can be any value. But you know, it can be float also, floating point also, it can be integer also. So what I'm trying to make a point here is A and B can be integer or it can be float also. So A and B values can be either integer or float point values. Okay, something like this. One more example, if you want me to take, val equals to 10.3 plus 20.4j. Or if you take one more example, A equal to 10 plus 20.34j. So this is also possible. A can be contains decimal numbers or point numbers, and B also contain normal numbers and point numbers. Anything is possible. Okay, and one more thing. If at all you want to use for example, if at all you want to use the binary form in place of real part, that you know, that is possible. But in the imaginary part, you cannot give it. Okay, if you really want to keep the real part into a decimal form or binary form or octal form, you can give it. For the restriction is you're not supposed to give any other forms apart from int and float in the imaginary part. Note 2. I'll show you practically all this. Okay. Note 2. In the real part, if we can use int value, then we can specify this in other forms like binary, octal, hexa. Okay. But for imaginary part, should be specified by using only decimal form. Okay. Decimal form or float. So let me show you. So if I take one value here, val equals to imaginary, sorry, complex data. 10 plus 20j. Print of val. Okay, if you are trying to print it, it will print as it is. It doesn't make any difference. If you see here, it is surrounding with the brackets, but that is negligible. So 10 plus 20j is the value. And if you see in another value, print of, and if you want to print the type of it, you can print it. If you want to see the type of it, you can simply print type of value. It will be complex. Okay, then we are good. Right? Now we'll see other possible ways. A equal to 10.2 plus 20j. Is this possible or not? Are we getting any error? No. It is possible. So I'm saying for real part and imaginary part, you can give the point values. There is no harm in doing that. You can do it. That's possible. And if you do 10.2 plus 20.3j, is it possible or not? As I said, so this is also possible. Print of B. So this is also possible. We don't get any error. You see the complex number, we are able to take it. But if you want to represent the value in a binary form, for example, I want to give 3 plus 2j. So this is normal simple number, right? In place of 2, I want to give binary value. What is the binary value of 2? How we can represent the 2 value in binary form?
0B10.
0B10. Exactly.
10.
0B10. So 0B10 is the actual value of what? Actual it will return 2 in the binary form. But this is not possible. That is what Python is saying. So in the imaginary part, you cannot give other forms like binary, hexagon, octal forms. But in real part, you can do whatever you want. Invalid syntax. Okay, let me comment this and take one more variable, t equal to. So now 3 plus 2j. So I want to keep the real part into binary form. How we can represent the 3 into binary? 0B
11.
11. So plus 2j. Just a minute. I gave O, not 0. Okay. 0B11 plus 2j. Now, if you print this, this will work. Sorry, I'm giving a D. T. If you print D, it has to print 3 plus 2j. Can you see here? So the point here to make, or the point here to prove is, you can, in the real part, it can be a binary form, or octal form, or integer form, or a floating point form. But if you go for the imaginary part, you should give only the decimal form or a floating point values. Other than that, nothing is allowed. Are we clear, guys? Is everything clear till now?
Yes, sir.
Yes, sir.
Okay. Next. For example, you might get one more doubt. I want to separate out, or I want to retrieve imaginary real value separately and imaginary value separately. Is that possible? Okay, let me repeat one more another way. Let me comment all this stuff and take another fresh variable, value equal to 10 plus 20j. What is imaginary value and what is real value here?
10 is real value, 20 is imaginary value.
Okay, yeah. So combination of these two will become a complex data type. But is it possible to retrieve the imaginary part and real part from this value? If you ask me, yes. How we can do it, val dot real. Okay, val is nothing but a variable of any complex number. Okay, val dot real, if you print, it will print 10. So you want to print, using this, you want to print only the real part of the val variable. Real part of the val variable is 10. So it will print 10. And if you want to print the imaginary part of it, val dot image, imag is nothing but imaginary part. What is output here? Line number 57 and 58. What it will return? It will return 10 here and it will return 20 here. Can you see? 10.0 by default, 20.0 by default. If it doesn't contain any floating points, also it will just simply append it. Are we good for complex data type, guys? That's all about complex. There is nothing much in the forms like integer. Other than integer, no other, nothing has, inbuilt forms, other forms. Are we clear till now? Any confusions or clarifications or any doubts? Okay, the silence is, I'm considering it as no doubts. Okay, so as I mentioned, the complex data types are generally using some mathematical applications or scientific applications or some electronics and electrical related applications we use it. But in regular web applications or normal applications, we rarely use this complex data type. But we don't want to miss any topic, right? So I'm just explaining everything. Okay, so tomorrow we have only 1 minute left. Tomorrow we'll discuss about the remaining data types like Boolean and string and all. From tomorrow onwards, it will be more. It's a bigger concepts. Those are very, very important concepts. Do not miss it, and I would request please join on time. 7:35. I would like to start the class at 7:35, but people are taking time to join. Please join on time. So I'll upload this, and tomorrow's assignments also I'll upload it, guys. Give me some time, maybe 1 hour or half an hour. I will upload in the classroom. I'll upload the assignment in the classroom. Please submit.